My dear children, welcome back to chemistry class, in which I will be explaining mixtures and their method of separation. Most substances around us contain impurities. For example, the rice we buy has stone, sand and husk in it. Milkman usually mix water and milk. Air we breathe contains chemical fumes, smoke and dust particles. Thus all substances have certain other substances mixed with them, which necessitates the need of their removal. Wow, so many gems! It's mouth-watering. I love eating colorful gems. Children, you can see different colors of gems, and before eating you separate your favorite colors, as you can see in the picture. I know very well. So you pick out the respective colors of your choice, like red, yellow, green, orange, blue, pink. Physically means using your hand, isn't it? As you all know that matter is classified into pure substances and impure substances. Pure substances is further classified into elements and compounds, which you have already learned in the previous video. Substances that are not pure are called impure substances, also known as mixtures. Most naturally occurring substances are mixtures. Now we will learn in detail what are mixtures. Mixture is an impure substance made up of two or more elements physically combined together. It can be broken down by physical means. No chemical changes takes place. Substances in mixtures are held together by physical forces. The properties of an element in a mixture remain same. And at last, mixture does not have any chemical formula or molecular formula, right? Okay. Now, mixtures can take many forms like solid-solid mixture, liquid-liquid mixture, gas-gas mixture. Any combination of solids, liquids and gases can be formed. So, let's summarize characteristics of mixture. It is an impure substance. Then they can be mixed in any ratio. Next, the properties of mixture are the properties of its constituent. Then, constituents can be easily separated by physical methods. Mixture can be either homogeneous or heterogeneous. Since the composition of mixture may vary, mixture are of two types, as you can see in the picture. Homogeneous and heterogeneous. Now we will study about their properties. Let me explain you these terms. Hetero means different. As you can see, different parts or phases of the mixture easily. Homo means same, so you cannot see different parts of the mixture as it is uniformly mixed, right? Just have a look with different types of mixtures we are coming across in everyday life. Air, salt water, sugar water, brass, solutions are examples of homogeneous mixtures, while soil, sand and water, fruit salads are examples of heterogeneous mixtures. So, a mixture is said to be homogeneous if its constituents are uniformly mixed, has same composition and it has same properties throughout. Examples of homogeneous mixture include solid in a solvent. Example, salt in water, right? Then miscible liquids, example, alcohol and water. Gaseous mixtures, example, air. Getting or not? Solid-solid mixtures of elements are generally not homogeneous, but when melted, forms alloys like stainless steel. Now, the question arises, what are alloys? So, an alloy is a homogeneous solid mixture of two or more metals or metals and non-metals is called an alloy. For example, brass, which is an alloy of copper and zinc, used for doorknobs, buttons and musical instruments. Stainless steel, which is an alloy of iron, chromium and nickel, used for making utensils and many others. Then solder. I'm not saying soldier, children. Be careful. It's solder, solder, which is an alloy of lead and zinc, okay? And is used in electronic circuit boards. Another important alloy is amalgam, which is formed by mercury and silver, or mercury with tin, which is used for dental fillings by the dentist. And many more examples are there, like German silver, bronze, etc. Okay. Now children, as I have told you that hetero means different, okay? So the mixture is said to be heterogeneous if its constituents are not uniformly mixed and it has different composition and properties throughout. This type of mixture can be easily separated by physical means. Examples of heterogeneous mixtures includes like sand and pebbles, pebbles like small stones, kerosene oil and water, then solid pollutants like carbon particles, soot in the air, muddy water, then mixture of iron filings and sulfur. Clear? Method of separating mixtures. Why constituents of mixtures are to be separated? Do you all know? There are many reasons for separation. It depends on needs and other reasons. A few reasons are as follows. Firstly, to remove undesirable material from a desirable material. Examples, small stones from pulses or rice. Secondly, removal of impure substances from pure substances. Example, straw from milk. And last, to improve quality of the substance. Example, removing water, separating water from milk. Clear, children? You can see the list of different ways of separating mixtures. Some of the methods like sedimentation, decantation, filtration, evaporation, you have studied in previous classes. Separation word refers to isolation of substances which occur together. Normally, substances exist in form of mixtures with little or more or the other component. Thus, in order to have a pure substance, separation becomes must, means important, and this separation can be done by physical or chemical methods. So the method to be used for separating a mixture depends on the nature of its constituents. We will consider the following three cases to learn the separation of mixtures, like mixtures of two solids, then mixture of a solid and liquid, and the last one is mixture of two liquids. Some of the methods of separating mixtures I'll be explaining in detail, like sublimation, evaporation, distillation, fractional distillation, by separating funnel and paper chromatography. Starting with separation of solid-solid mixtures. You all can see this woman. Yes, what is she doing? She is trying to separate chaff or husk from grains by the method of winnowing. So, winnowing is a technique for separating a mixture of two solids. This method is used if there is a great difference in weight between the two. The mixture is put in a winnowing fan and is shaken into the air so that the light particles are blown with the wind. Other method you can see in this picture is sieving or separating gravel from sand. You can also see your mother at home when she is sieving the wheat flour to remove wheat bran before kneading the dough. And after that, hot puris are served at dining table, isn't it? Okay, so moving to another method of separating a solid from a solid mixture. I am talking about separating iron filings from mixture of iron filings and sulfur. How it can be separated? Any guess? Yes, come on. By magnetic separation. Magnet attracts certain types of metals like iron and nickel. So, the mixture of magnetic material can be easily separated by this method, like separating iron from a mixture of iron and sand or iron and sulfur. Clear? But if we try to separate iron from a compound of iron sulfide, that is impossible. The experiment is given in your book. So the properties of a compound are different from those of a mixture. How? Let us see. See the differences between mixtures and compounds in the given table. Elements or compounds just mix together to form a mixture, and no new compound is formed, while elements react to form new compounds. A mixture has a variable composition, while in compounds, composition of each new substance is always fixed. A mixture shows the properties of constituent substance. In compounds, the substance has totally different properties. Mixtures can be separated fairly easily by physical methods, while constituents in compounds can be separated only by chemical or electrochemical reactions or electrolysis. Right? With advanced science and technology, we are able to separate different mixtures with different methods, devised and formulated for specific purposes. Like we'll start with sublimation. The change of a solid directly into its vapor state without passing through the liquid state is called sublimation. It is the method by which sublimable solid can be separated from non-sublimable solid. Now the given experiment shows that on heating the solid-solid mixture in an evaporating dish, the sublimable solid like ammonium chloride, iodine, naphthalene undergoes sublimation and gets separated from sand or common salt used as non-sublimable solids. During this process of sublimation, fumes are seen which further changes back to solid. Hence, it is a physical change. Why these sublimable solids directly changes to gaseous state? Let's think. Because particles present in the solids have enough energy to change from solid and convert into gaseous state. As you can see, the iodine vapors, which is purple in color and looking so beautiful. Children, I will take few more examples of sublimable solids that you can see at your home in your cupboard, that is naphthalene balls, which is kept with clothes so as to avoid any kind of damage of woolen or silk clothes by moth. And that is why these balls are also known as moth balls. Another example is camphor, also known as kapoor, is used in temples to offer the lights to God at the time of prayers, even at home also during Aarti. Next, separation of solid liquid mixtures. But yes, children, if the solid is insoluble, means does not dissolve in water, then it can be separated by the sedimentation followed by decantation and filtration. Clear? And if solid is soluble, then mixture can be separated by evaporation and distillation. Definitely, you all must have recognized this process of settling down of heavy solid at the bottom on prolonged standing. Yes, children, very good. It is sedimentation. After sedimentation, the process of obtaining clear liquid by pouring into the other container without disturbing the settled solids is called decantation. Another method of separating solid liquid mixture is filtration. In this process, insoluble component is removed from a liquid mixture. The clear liquid obtained from the suspension of an insoluble solid and liquid by the process of filtration is known as filtrate. Impurities left on the filter paper is known as residue. Now, in a solid liquid mixture, when the solid is soluble in the liquid, the method used for separation is evaporation and distillation. Firstly, I'll be explaining you what is evaporation. Evaporation is a process in which liquid state changes into gaseous state due to increase in temperature or pressure. In this process, the liquid constituent of mixture evaporates, leaving behind the solid constituent. The given experiment shows how salt is obtained from salt water. I have taken salt solution in a china dish or evaporating dish and then after that placed on a wire gauze, right? On heating the liquid, it changes into vapor state. When whole of the liquid is evaporated, I have removed the Bunsen burner, allowing the china dish to cool down. Finally, what is left behind? Salt is collected from salt solution. The process of evaporation is used on a large scale to obtain common salt from seawater. In this seawater is trapped in shallow ponds and allowed to evaporate in the sun. After few days, white solid particles of common salt is left behind. Let us learn another method of separation, and that is distillation. What is distillation? It is method of separating pure water from seawater or salt solution. Distillation is the process of separation of liquid from its solution with the solid constituent by evaporation and condensation to get back the pure liquid. And the pure liquid obtained after this process is known as distillate, which is collected in a separate flask. Okay? Pure water or distilled water obtained by the process of distillation can be used in car batteries, baking, baby formula means that is preparing syrups for infants, ice cubes, preparing coffee, etc. Now before I start explaining separating methods of liquid-liquid mixtures, let me introduce you about types of liquids. So, the two types of liquids are miscible liquids and immiscible liquids. What is the difference between two? Liquids that can dissolve in one another are called miscible liquids, while liquids that do not dissolve in another liquid are called immiscible liquids. Children, look at the given picture and try to identify the miscible and immiscible liquids. Yes? So, since the oil is insoluble in water, forms a separate layer. It is a immiscible liquid, while ethanol is soluble in water, hence forming a single layer and are called miscible liquids. Proceeding with the separation of miscible liquids by the process of fractional distillation. Fractional distillation works on the basis of the difference in the boiling points of liquids. The mixture of alcohol and water is kept in a distillation flask and heated. So, the liquid with lower boiling point, that is alcohol, evaporates first, gets condensed, means cools down in the Liebig's condenser and is collected in a flask, while the liquid with the higher boiling point, that is water, remains in the distillation flask. So simple. So the separation of mixture of miscible liquids by distillation is called fractional distillation. Fractional distillation can be used to separate nitrogen and oxygen from liquid air. Then constituents of crude petroleum such as petrol, diesel, fuel, oil, paraffin and kerosene are separated. At last, ethanol is separated from fermented liquor. Look at the differences between simple distillation and fractional distillation. Carefully, huh? Simple distillation is used to separate mixture of miscible liquids with sufficiently large differences in their boiling point, while fractional distillation is used when difference in boiling points is quite less. Simple distillation is used to obtain pure water from impure water, while fractional distillation is mainly used for crude oil refining. Now we will learn how to separate immiscible liquids. Miscibility describes how well two substances mix together. So if the liquids do not mix with each other, this will give two-layered mixture. So the question arises, which liquid will be on the top of the other? Let's see whether it is oil or water. How to separate water and oil with a separating funnel? As we can see in the picture, oil is forming the upper layer since the density is less, and water is forming the lower layer since the density is high. Let's see how the apparatus look like. Now the mixture of immiscible liquids is poured into the separating funnel. Higher density liquid will settle at the bottom. As soon as the tap is opened, the higher density liquid will come out into the beaker. Soon after that, we will close the stopper. What do we observe? That oil remains in the separating funnel and the water in the beaker. Clear, children? Moving to the last technique of separation, that is chromatography. Chromatography is another interesting technique of separating mixtures used to separate the constituent of a small quantity of mixture of substance that dissolve in the same liquid. This technique you will study later in detail. Later means in higher classes. Paper chromatography is used to separate complex mixtures such as colored dyes from ink. What are the applications of chromatography? Applications of chromatography sounds very interesting, children. So I'm going to tell you real life examples which are as follows. In pharmaceutical company, then you must be watching CID. Yes? So in hospitals, to detect blood or alcohol levels in patients' bloodstream, and to compare a sample found at a crime scene from suspect. Then to determine the level of pollutants in water supply. And last, purifying chemicals for making product. At last, I have summarized the entire methods of separating different types of mixtures that you have studied from the beginning: chromatography, separating funnel, fractional distillation, distillation, evaporation, sublimation, filtration, sedimentation, followed by decantation. My dear children, I hope each and every topic is clear to you. You need to listen the video regularly by giving pause after 10 minutes so that you don't feel stressed. A small message for you all. The value of pure substance is always more than a mixture. Diamond, when pure, is the most expensive substance on earth. But when a little amount of impurity accompanies, the worth of diamond decreases. That is the reason why we have phenomenon called separation. Let's try to separate negativities from your life by praying to God and showing positive attitude so that we rejoice life in a meaningful way. I know every human being is a mixture of light and darkness, trust and fear, love and hate, but mixtures of problems, obstacles, hurdles, and defeat in the pot of struggle makes a delicious dish of success. Thank you. God bless you.